Okay, the periodic table. I think the best way to start a video about the periodic table is to show you a periodic table. And here it is. This is how the periodic table looks. And there is one that's like this in my classroom, but most periodic tables don't print like this. And the reason why is there's so many columns on here that you have to print them really small to get them all on there. So usually what people do, or what companies do when they make periodic tables, is they take this block right here and they sink it down below and they just stick it at the bottom of the periodic table, so that way they can mush these two sides in together. So what you wind up with is a periodic table that looks more like this one. And I've taken everything out of this one because I want to talk about just the big picture. So this is what the periodic table looks like usually when you see it printed. So right down here, here's that chunk that gets sliced out. Okay, so let's start off with the top of the periodic table. Let's start out talking about hydrogen and helium. Right here they are, hydrogen and helium. So these two kind of get us going because these guys are members of what's called the first period. So this is a period. Oops. A period is a left and right row on the table. So here's the first period, second, third, fourth, fifth, sixth, and seventh. And since these guys got sliced out, they were part of the sixth and the seventh periods. But going back to hydrogen and helium, hydrogen only has one electron and helium only has two electrons. So it just so happens that the first place that you can put electrons around a nucleus happens to be able to hold two electrons. So that's why the first period only has hydrogen and helium in it. So what happens if you have an atom that has more than two electrons? Well, they have to go into a bigger space. So they go into what we say it's a higher energy level. It's just a bigger atom. And that is the second period. So as you go down this table, what happens is you keep adding on new and new periods. Atoms tend to get bigger and bigger. So that's what we call a periodic trend. Okay. So why does the periodic table kind of fill in down here, or why does it, why is it blank here, but then it's got atoms here? Well, as the atoms get more and more electrons and they get bigger and bigger, the electrons have more and more places to go. So that's why the table gets wider and wider like that. Okay, so let's see. Okay, so we've got periods. Periods are the left and right rows. Now let's talk about groups. What's a group? A group is a column, like this column. This column is called the noble gases. No, you don't need to memorize that for me. But the neat thing about, or one neat thing about the table is that a column has similar properties. And to varying degrees that's true, but these guys in this column, these guys, they are chemically pretty much non-reactive. They're not completely non-reactive, but they're so boring that we don't talk about them a lot in chemistry class. Okay, so what about other groups? What about this group right here? What about these guys? These guys, if you breathe these guys, you're going to die. These are some deadly gases in this group right here. Chlorine and fluorine and bromine and iodine, those things. So that's kind of a useful thing about the table. Or this group over here, these alkali metals. If you throw these guys in water, they'll catch on fire. Not hydrogen, but these other guys will. And that's kind of neat. So how did people use this? They could predict things. Like when people were still discovering elements, let's just say that nobody knew what this element right here was going to be called. Well, what people would guess was they would say, oh, well, it probably is going to behave like this one, and it's probably going to behave like that one. And so they could use that to predict what the new element was or what it was going to be like, and that worked. So the up and down columns, those are called groups. So I'm going to erase a lot of these comments here so I can do one last thing. Okay, the last thing I want to do is I want to talk about who's on the table. It's metals, nonmetals, and metalloids. So let's do this. I'm going to shade in this one, and 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 this one, until I get down to 1, 2, 3, 4, 5 of these. So about like that. Okay, so what do we have here? What I've done here is I've kind of drawn this line that seems to kind of cut the table into pieces. And everybody over on this side is a metal. And everybody over here in this little triangle chunk, these guys are non-metals. And these ones that I shaded in orange here, they're kind of like, they don't know whether they're a metal or a non-metal. They're kind of in between, so we call them metalloids. Some books will call them semiconductors. So how about that for a quiz question? What's there more of, metals or non-metals? Well, the answer would be pretty easy. Look at all these metals. These guys are all metals. And then over here, these guys are the non-metals. Way more metals than non-metals. You might be asking, hey, wait a second. I thought hydrogen over here, that's a gas. That's not a metal. Well, hydrogen is special. It's the lightest element. And if you want it to behave like a metal, you can do it. You just have to compress it a whole lot. And once you compress it a lot, it behaves like a metal. So anyway, I'm pretty much done. If I was going to ask you to take 1 point away from this video, if there's going to be one thing that you were going to remember, it would be that I would want you to remember that this table is just jammed full of information. There's all kinds of good stuff that we can figure out from the periodic table.